Good day, everyone, and welcome. Thanks for joining our webinar today. I'm Laventa, Customer Success Manager here at Midori, and I'll be talking about how you can maintain a well-controlled code change history and make your team of developers more effective with commit policies. If there is a group of professionals that is famous for resisting any rules and regulations, now that are the software developers. And not because they are anarchical or want to tear up the fabric of a well-adjusted team, but simply because the process of writing code is most of the time easier in an uncontrolled fashion, without caring about anything else, like company regulations or another team member. They are often thinking about hard problems and just like to get coding when the solution starts to form. And we can't blame them for this, but in a large organization with tens of thousands of developers having no discipline in contributing code to a product, it just won't work, especially in the regulated industries like aviation, automotive, pharma, medical, or banking, where you have to comply with industry standards, regulations, as well as governmental laws in order to stay in business. Software products are mission and safety critical in these industries, and the code changes, particularly the details about what has been changed, where, and why it was necessary, need to be captured. So it's easily understood and followed by auditors months or even years later. In today's webinar, I'm introducing Commit Policy for Jira, an app we created to help DevOps teams, lead developers, managers, and the developer community in general to create the balance between company rules and the way they like to work on software code. Now, before we start, just a few usual housekeeping notes. This recording of this presentation will be available on YouTube soon after it concluded. During the presentation, please use the live chat feature to ask questions, or if you're watching the recording, please leave your question as a comment below. We will answer questions at the end, or if won't have time for all, please submit them as comments anyway, because we will answer them in a follow-up blog post on our blog. So if you haven't already, please feel free to subscribe to that as well on our website. Now, before we dive into the nitty-gritty, let's get started with a background on Midori, the company behind Commit Policy for Jira. We are Midori, a long-time member of the Atlassian ecosystem. We've been around for more than 10 years, working with and also developing apps for the Atlassian products. We are also a top vendor, which is an official certificate that Atlassian gives to app vendors who live up to their high standards of software and support quality. It also tells you that our apps are always compatible with the latest Atlassian host applications, and we issue maintenance updates whenever needed. Among our customers, we count many global companies from industries like technology, healthcare, entertainment, as well as governmental organizations. But now, what is Commit Policy for Jira and why should you choose it? First of all, it's an actively developed, maintained, and supported app for more than 3 years. It's appreciated by customers as well. It has many positive reviews, and if you read through them, they tell you that it's a must-have app if you want a really organized, consistent code repository that is easy to follow, both for new developers on the team or auditors. Commit Policy is a Jira app that provides a straightforward and friendly way to manage and improve change control over your source code and make code reviews faster and more efficient. But what really differentiates it apart from similar apps is that it is version control system independent, meaning that it works with all the major centralized and decentralized version control systems like Git, Mercurial, or Subversion. Also, there is an extra attention paid to making the verification process as frictionless as possible. For example, by using a special technique called local verification. The idea here is to make the frustrating process of correcting rejected commits less frustrating, and that way to increase the adoption rate within the developer team. Now, what are we going to cover today? First, we'll look at the problem at hand. Why do you even have to care about a clear commit history? Then you will understand how a commit policy works through a simplified schema. Then we will break down the components of a commit policy and see what you can customize. Once that's clear, we will go through the steps of installing the policy and make it work in your repository. And then I'll show you that commit policies are platform agnostic. You can use them in any development environments or version control systems, as you are not tied to any one solution. And last, I'll try to help you with ideas and tactics to successfully communicate and introduce this new tool to your team and hopefully avoid resistance. Now, what's a problem that needs attention? The exact reasons here can be all specific from organization to organization, but here I would like to highlight 3 major causes why commit policies can make a difference. In certain industries, development work, particularly source code changes, is strictly controlled by processes and regulations. The format and the thoroughness of how code is committed, documented, approved, accessed, and changed can all be subject to specific rules. A commit policy can be your help as you strive to comply with these internal regulations. You can mirror your company's different security, documentation, or other guidelines in commit policy conditions, so your team will never forget to follow those. First of all, code changes shouldn't happen without a well-described technical reason or business requirement in the background, however insignificant they might be. In other words, the change must be traceable to one specific requirement, specification, user story, or test. Even more so, this link must exist for a long time as in the future, so that the audit, like 15 years later, can still detect a potential software defect. Like here's a real life example for you. I want to give from one of the customers who works for an avionics supplier company in the US. Like they are obviously regulated by the FAA, the Federal Aviation Administration. And they told us that when the authority come knocking to conduct an audit, they are also looking at changes in software code that supports the hardware they are manufacturing. And when the auditor points at a certain change made to the code, they need to be able to explain what requirement made that change necessary and who performed and approved the change. Commit policy for Jira ensures that every commit is linked to a Jira issue and submitted by the responsible developer assigned to the issue and not someone else, making the audit less stressful and quicker for them. And this also leads to a third common advantage of using commit policies. Since granular code changes can be verified right on the developer's machine before they're even committed, when it comes to code review, there won't be formal errors like a missing commit message or wrong committer, wrong target branch, wrong file, and so on. Instead, the reviewer can focus on what really matters, the code and the business logic itself, making the whole process more effective. In this way, commit policies contribute to the effective workflow of how your team delivers software. And if you think this is an isolated problem that does not affect you, think again. It has been reported that software failures caused $1.7 trillion of financial loss last year alone. And as we depend on software more and more in every domain of our everyday life, this trend needs to be addressed. And even big names, as you see, like Apple, Amazon, and British Airways, who allocate enormous budgets on software verification, were among the affected companies. So better deal with software traceability and quality, because who knows, maybe next is your company. Now let's get to the inner workings of commit policies and try to understand how they work. And now again, what commit policy for Jira does is verifying the committed changes to your version control system against a set of rules. Now, version control systems can be centralized or distributed. I generally assume here that you are familiar with the differences between the two types of systems, but let's just have a reminder very quickly. In case of a centralized version control system, there is a single central version of the code base, and developers all commit changes to that, one commit at a time. Subversion is the most widely used centralized version control system. With distributed version control systems, all developers have a working copy of the code base, including its history. They can commit as many changes as they want into their local repository until they're ready to push their local changes to a remote server where the production-ready code is managed. Git, Mercurial are probably the most popular distributed version control system implementations out there. The commit policy app works similarly in both architectures, but for the sake of simplicity, in this demonstration, I will use the example of a centralized repository. So let's walk through the steps. The whole process starts when the developer commits a change. Before the commit is actually accepted to the target repository, the hook scripts installed to that repository will be executed. Generally speaking, hook scripts are little programs that are automatically ran by the version control system at certain events, most importantly, when a developer commits a change. We will discuss how to install hook scripts later, but for now, just know that the hook script is responsible for collecting information about the commit and for sending that to the commit policy app in Jira. Now, the information includes the changed files, affected branches, affected tags, the committer username, the commit message. All that gets sent to Jira with the commit policy app installed. The hook script also tells the app which commit policy to verify the changes against. Now, having all these, the commit policy app evaluates the commit against the given policy, which can lead to two types of results. If the commit policy was not fully satisfied, the commit is rejected. In the rejection message, the app tells you why the commit was rejected, so you know how to fix it. And once you fixed it, you can recommit the change and see if it satisfies the policy now. Only if the policy is fully satisfied, the commit is accepted and allowed to enter the target repository. In a very simplistic form, this is the way code changes are verified. Now I mentioned the local commit verification, and I also said that this is a big deal. And I want to dive deeper into this local commit verification feature, because this is a game changer when working with distributed version control systems. This is also something you won't find in other apps with similar functionality. So first, let's see how a developer usually works and how her work is verified. Now, the developer works on some code and keep committing changes to the local clone of the repository. Now, no verification happens here, and everything is accepted as is. Verification happens only when the changes are pushed to the remote server. Now, imagine that there are some non-compliant commits, therefore all the changes pushed to the server got rejected in one in one go. So it's too late for her. It's frustrating because she may have created the problematic commits days before. So now she needs to recall, why did I do this, and what's the underlying requirement in Jira. It's too late to correct the commits. Then she needs to use the Git operation called interactive rebasing to find and fix the problematic commits. And this is not only painful, but also an unnecessary waste of time. Now, on the contrary, let's see why the Midori approach is different. With local commit verification, every commit is checked before accepted to the local clone. If there is a problem, the commit gets rejected right away. And as with every type of problems, the earlier you detect a problem, it is easier to fix it. So the developer can take a quick second look, decide about the fix, and recommit that single change, just that single change. When all her work is pushed to the server, the same rules verify the commits again, just to be sure, and obviously accept all the changes as they have already been verified at commit time. So there's no surprises there. Less wasted time, less frustration, faster code reviews are the results, as no major issue can surface this way. Local verifications are optional, but we strongly encourage using this approach. And now that we know how the changes are verified, let's break down each policy themselves and see what they can control. Once you install the app, you can find the commit policies under the commits menu right in the top of the Jira screen. Here you can manage your policies, add new policies, added existing ones, and apply them to repositories. A commit policy is basically a set of commit rules. You can think about it that way. Now let's open one for editing. When you pull up a commit policy for editing, first you need to name it. Following is a description that should indicate the purpose of the rule. You can also add a more detailed rejection message here. If a commit is rejected, there's always by default a short explanation why it was blocked. But here you have the option to phrase a more elaborate message that informs the developer about a failed commit and explain in more detail why a commit was not compliant. As a best practice, in the rejection message, we suggest showing a positive example that would be accepted. This makes the developer's life easier. Then you have a few further options that pertain only to distributed version control systems. Namely, you can decide if commits that have already been verified on another branch should or should not be verified, or if you want to verify merge commits that are special kind of commit and usually don't have the same importance than regular commits. Moving on in the configuration, you can see the rest of a policy's components. There is a 3-level hierarchy of components. Each policy consists of rules, and each rule consists of conditions. Now, let's start with rules. Rules can verify tags, branches, and commits, and they are grouped by these categories accordingly. Now, let's see the tag rules first. You can limit the scope of this rule by limiting to tags with names that match a given pattern. This gives you extra flexibility, as the rule won't be considered if a commit is out of scope. If this rule needs extra explanation, you can add a rejection message that will shown only when this rule is breached. And as I said before, you can define conditions within a rule. As in case of tags, you can set up 2 types of conditions. You can either check for the name of the tag and use a regular expression to require it to follow a certain pattern, contain certain characters, be a certain length, and so on. You can use this condition to enforce naming conventions for tags, like enforcing semantic version numbering, and in the format, like major version, .minor version, .patch version, like version 4.5.6. Another condition you can have for tags, for tag names, is to require them to contain an issue key. You can narrow down the circle of issues that you expected the tag name to contain with a JQL query. Going forward, you can choose to also activate a branch rule. Similarly to tag rules, you can limit the scope of branch rules to branches with names that match a pattern. You can also add a custom rejection message here as well. Just like with tag names, you can set up a condition for the name of the branch, or require it to contain an issue key defined by a JQL query. A good example for this could be to require an unresolved bug type issue to be included in bug fix branch names. So you can refer to the bug right from the name of the branch. Next are the rules for commits themselves. With those, you have even more options. In addition to limiting to given branch names, you can also limit this rule to certain directories in the repository, applying stricter rules to selected directories or branches. And of course, in case of rejected commits, an additional rejection message can explain the detail of what this rule verifies. There are a number of commit conditions, so let's see them one by one. First, let's start with conditions you can use to control the commit message. As you can see here, you have the option to require a certain pattern. The regular expression gives you a wide a wide variety of criteria, but you can also choose one of the listed examples and just customize one of those. A real-life example could be to require commit messages to have a minimum length, like 20 characters. Or you can go a little bit stricter and enforce the Git 5072 rule, which is considered a best practice. This rule requires a maximum of 50 characters long first line, like a summary for the message, then a blank line, then breaks the lines at 72 characters, so it's well readable on an 80-column terminal. If you want to learn more on the 5072 rule, visit our blog. There is a great article about it. As you probably guessed by now, you can also enforce the mentioning of an issue key or keys in the commit message text. JQL again gives you a wide range of options, as you can see the examples. To put this condition to good use, you could require exactly one unresolved issue from the currently running Scrum sprint to be associated with every commit. In the next section of conditions for commits, you can control if the developer changed the files that they were actually supposed to. With this condition, you can control what type of files should or should not be checked in, or in which directories. This, as you see, gives you granular control over what can be changed in a repository. In a production environment, for example, this could be used to reject all temporary, hidden, or local-only files from being checked in to the repository. Staying with the changed files, the next condition allows you to control in which directory are files changed. For example, if you have a test results directory to collect test results consistently, this condition can require a test type issue to be mentioned in the name of each subdirectory. Commit conditions can also dictate who can commit changes. You can verify, for example, if the user who tries to commit code is indeed a Jira user and has a valid Jira account. Or you can go further and require any committer to also be part of a Jira group in order to be granted access. For example, if you're working on a mobile app for Android, you can set up this condition to accept commits only from Jira users in the Android developers group. You can also choose to check for the email address or the username of the committer user and require those to follow a predefined pattern of your choosing. You can use this condition, for example, to also make sure that the commit is submitted by the developer who is assigned to the issue, or to check for your company domain in the email address of the committer. Okay, so now that you defined your conditions and the commit rules within your policy, you can save it, and now you obviously want to apply to a repository that you created the policy for. We invested into making the installation of hook scripts a breeze. If you go back to the commit policies, there is an option to apply to a repository for every policy. If you select that, you are greeted with a wizard that guides you through the process. What we're basically doing here is preparing the hook script that we already mentioned earlier. This is the point when we already created our policy. We just need a pre-configured downloadable hook script package, an actual zip file that we can take and place into our local or remote repository. This wizard helps us set up a few things and grab the hook script at the end. So let's start. First, select what version control system are you using. Then select if you are planning to install this into a central repository or to your local clone. If you selected centralized version control system in the previous step, this option is obviously not offered. Then select what operating system hosts the corresponding repository, and then proceed to the next step. The hook scripts are developed in the Python programming language, which is the most widely used platform-independent interpreter language. In this next step, the wizard verifies if you have Python runtime installed on your computer that hosts the repository. If you don't, it's a good time to install. You don't have to worry about it because there are many convenient Python installers for every major operating system. If you do have it installed, just confirm it and proceed to the next step. At this point, your hook script is ready to be downloaded. It's actually a script package that downloads in a zip file, so you just need to hit download on this screen. And install the hook script by unzipping to the folder in your repository where your version control system expects it. So this is a good repository example. So we will unzip them to the hooks directory. And once you did that and the files are in place, you can test your configuration. You can do that by intentionally committing something that should be rejected, then committing something that should be accepted to test your configuration. Now let's look at a quick example here. Let's try to commit something to the repository where we install the commit policy, which verifies if the commit message contains a Jira issue key and if that mentioned issue is an unresolved in-progress issue. Now, as you see, there has been some changes made, and first we try to commit these without mentioning a Jira issue key. The commit is rejected immediately. So remember, we installed the commit policy on our local repository, so the commits are rejected immediately. Okay, now let's start correcting this and add the Jira issue key and commit the changes again. It's rejected again. Now let's see what the rejection message says. It says start the commit message with the key of an unresolved in-progress issue. So the one we added was clearly the wrong one. Now if we try to correct this and commit again, it's now accepted as all rules in the policy are satisfied. Here's a quick example for checking tags. The policy in play here expects us to follow semantic versioning in tag names. So for example, version 3.4.5. We created a tag here named version 1.2, which clearly doesn't respect the rule. If you try to push it, it's rejected as the format is not correct. If you try to rename the tag and push it again, then this attempt is now successful as the rule in the policy is satisfied. Similarly, an example for branch names, this time under Subversion. The rule here verifies if the branch name contains the key of a task type issue. We started a branch in Subversion and try to commit that. Now it's rejected as we didn't give an issue key in the branch name. But after we correct this and commit again, it's now accepted. And with that, you tested your policy and you are done. It's alive in your repository, guarding it from non-compliant commits. It's important to understand that the hook scripts does not contain the policy, but connects to the commit policy app in Jira and refers to a policy by its ID at every verification. It means that after installing the hook script, you can freely reconfigure the policy in the commit policy app anytime, and the changes will be immediately reflected in every repository that has a hook script relying on that policy. Commit policy for Jira provides a functionality that doesn't tie you to a specific version control system or integrated development environment. You can use the app in any scenario, tool, or environment you choose. It's compatible with all the major version control systems like Git, Subversion, or Mercurial. It also supports the popular web-based version control system hosting services like GitHub, GitLab, or Bitbucket. For Bitbucket, it even has a free connector app that makes it easier to integrate between Jira and Bitbucket. Plus, through the public and well-documented REST API, you can implement commit policies in any custom version control system, custom environment, or third-party application you might use. It is completely compatible with every standard version control system client, whether it is a command line client, as you just saw in the testing, a GUI client like the FreeTortoise family, or the ID integration like IntelliJ IDEA, Eclipse, or Microsoft Visual Studio. And as I mentioned, a couple of thoughts about the REST API very quickly. The commit policy for Jira REST API extends the standard Jira REST API by adding new endpoints. The endpoints extend the built-in functionality, but also reuse what is already available, like authentication. Here are a couple of important REST endpoints you can use. One is there for commit verification. One is for listing existing policies, and one for generating hook scripts programmatically. The REST API allows you to integrate commit verification into any version control system you are using, if that is using the standard protocols for code change handling. To learn more about it, you are always free to look up our detailed API documentation on our website. You can find it under the commit policy for Jira app documentation. Now, I hope you feel a bit more familiar with the concept of commit policies now and agree that a well-organized and efficient developer team can take great advantage of them. But are the rest of your team also on board with this? How will you take this idea back to your developers and introduce it? I know from experience that developers tend to have this rule aversion problem. They won't welcome anything that feels like some kind of new rule and is, especially if it's enforced on them. So I wanted to leave you with a few ideas on how to get your team's buy-in and have a smooth transition into using commit policies. The first idea I want to give you is to communicate this idea of commit policies before rollout. Make an informal announcement to the team and choose a casual format, obviously depending on how large the team you need to talk to. If it's a smaller team, I would do it during a coffee break or while grabbing a few beers after work. The less it feels another corporate rule and more like a professional decision on your part, the better. Also, don't be hypothetical and abstract. Prepare and bring real-life examples of occasions when a controlled commit or a clearer change history could have helped to avoid extra work, a bad user experience, or financial or business loss. And also, encourage local commit verification, because the sooner a non-compliant change is caught, the cheaper it is to correct. Local commit verification doesn't let the developers pile up a bunch of soon-to-be rejected commits locally, so it reduces frustration when the change is pushed to the server and at code review. And of course, there will be less and less rejected commits as the team gets used to the rules for the repository. And I also recommend using the Team Playbook by Atlassian. It's a great collection of serious games and standalone plays with step-by-step instructions for conducting them. I particularly found the 5 whys analysis to be a good approach to give your team an understanding of a problem and its impact. It will fit the topic of commit policies and help your team understand why it is a problem and what can happen if they don't address this on time. And now with that, I would like to thank you for your attention so far and encourage you to reach out to me if you have any questions or comments. You can always use my email address that you see on the screen. And also, if you liked what you heard, give our other apps a try as well. Those cover slightly different aspects of productivity for business users as well as developers. Better PDF Exporter exports your Jira data to business documents in PDF format. Better Excel Exporter creates native Excel files and reports from Jira data that could be also enhanced with pivot tables and charts to create a real business intelligence solution for Jira. And Better Content Archiving is a content lifecycle management app for Confluence, mainly for large instances. It helps keeping Confluence content always up to date and streamlined. And now I think we have time for a few questions if you have anything on mind. I received a couple of questions beforehand, so I will tackle those. So the first question was about its relation to Bitbucket. How does it work with Bitbucket? So as I mentioned during the presentation, with Bitbucket Server, you are in luck, as we also have a free app called Commit Policy for Bitbucket. What this app does is basically connects Bitbucket with Jira and gives you an easier and a user-friendly interface to apply your policies to Bitbucket repositories. So you can search for it on the Atlassian marketplace and give it a try as well. It would make integrating the commit policy for Jira app with Bitbucket very quick and easy. Another question was, can I use the same policy on the server side that I used on the client side? Yes, obviously you can do that, and you can not only do that, it's also recommended to use the same policies on both sides, so there won't be surprises at push time. So if you think about it, if you've been checking your commits against one set of rules, it only makes sense to in most cases to check for the same set of rules when it's pushed to a central repository or server. There was someone who was concerned about regular expressions. What if I'm not familiar with the regular expressions, but need something different than what is shown in the examples? Yeah, so thanks for mentioning the example. The examples are very important. There are a lot of regular expression examples that you can choose from, but if you need something that's more complicated or not there, you can start with the Wikipedia article. I think that has a lot of details and resources, and there's also a good tutorial blog post on Medium.com as well. If you Google for regular expression tutorial on Medium.com, I'm sure you will find it. If your goal is to learn how to write regular expressions, there is also a website called regex1.com. But all these resources are listed on our website in the commit policy for Jira documentation. We also collected these to help you get more familiar with regular expressions. Okay, if that was all the questions, then I thank you for your attention again. If anything comes to mind later, don't hesitate to submit that as a comment below under this video. We're always here to answer, and you can obviously reach out to us via email or our support portal, or you can even tweet us. We are always happy to hear from you. Thanks for your attention again, and see you next time.